All right, so the Rho method is a way to test the quality of hash functions, and it's also used in attacks against public key systems to do things like reverse the discrete logarithm problem. And it works like this. I often wondered about this when I saw rainbow table attacks for the first time. This is a way to understand the quality of a hash function. You hash something. Start with a word and hash it with MD5 or whatever hash algorithm you're interested in researching, and then you hash the hash value, and hash that hash value, and hash that hash value. And if you do that, you'll just be going from one to another like this. At some point, you will hash something, and it will give you a number you've seen before. And then you'll just go around this loop forever. And it turns out, if you take the total number of hashes possible, the length of this tail will be approximately the square root of that number, and the length of this loop will be approximately a square root of that number. So if you have MD5, for example, that's 128 bits, there are 2 to the 128 possible hashes, and so that'll take you about 2 to the 64 calculations to get to here, and about 2 to the 64 calculations to go around. And that just works from a simple calculation based on what they call the birthday paradox. If you had 2 to the 64 random hashes, there would be about 2 to the 128 pairs of hashes in there, and you'd have a chance that one of them will collide. So since you can demonstrate this, again, with a simple Python program, and let me bring it up here. If I clear this and move to there, and this is the row. All right, so so what this is going to do is it's going to import the hash library in Python, and it's going to start with just the word password, and then 50 times it's going to cache it with MD5, but then keep only the last 2 characters of it. So I get a very short hash that's only 2 characters long. Oh, you managed to crash it. Oh, that's good. Yeah, I mean, show me how you crash the crib drag program, and I can maybe fix it. I guess if you go off the end, if you get a number too big, it'll probably crash. It's a pretty sloppy program. Anyway, so if I run this, it'll show me these hash values with just 2 characters, Python 3. This thing C106.1. All right. So it calculates these 2-digit hashes, and then hashes the hash, and hashes the hash, and hashes the hash. Every time it hashes H and puts the answer in H. And you can see where this repeats by just dragging the width of the window. So around some, it's not wrapping around the way it should. How rude. Well, let's just run it again here. Oh, we're getting close. See, I have an EE1E, and here I have the 1E again, so I'm close. I guess I can do it by just running it again every time here. Well, now it's expanding the way it should. Good. All right. Don't know what was going on before. All right, let's try it now. All right, let me put it in a text editor that isn't going to do this weirdness. For some reason, the terminal window is not letting me resize it and wrapping around correctly. So I'm going to clear and run it again and just copy this data and put it in a text editor that will wrap around in a reasonable way. All right. So now I should be able to do this. There we are. A8, A8, C0, C0. Now this is the loop from here to here. And the loop starts at this 1E. EE we never see again, but 1E goes around. So now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, it's 15. 15 characters in, I hit the loop, and then the loop is 15 characters long. And that's with 2 hexadecimal digits, that's 256 possibilities, so the square root of that is 16. So you see it came out pretty close. About 16 to get into the loop, and about 16 to go around the loop. So that's just a simple mathematical property of hash values, and there are some flags to find here. starting with a different value, going to 3 and even more characters, and you'll have to write somewhat more sophisticated programs. The first couple you can probably do the way I did it there. The last one has 32 bits, so it's going to be 2 to the 16, which is 65,000 hashes to get to the loop and 65,000 hashes around the loop, so you'll have to program detecting it. But that's the Rho method. And I'm going to stop this recording.